Hallucigenia was an ancient marine organism that lived during the Cambrian period and is considered one of the most bizarre and controversial creatures in the history of paleontology. Its name was not chosen randomly. Early researchers were unable to determine which side of the animal was the top, which was the bottom, or even where its head was located. Because of this extreme confusion and its dreamlike, almost unreal appearance, it was given the name Hallucigenia, meaning something resembling a hallucination. Hallucigenia had a soft, worm-like body, but its structure differed radically from that of typical worms. Its body was elongated, slender, and lacked clearly defined segments. Along one side of the body were paired, soft, leg-like appendages known as lobopods, while the opposite side was covered with long, sharp, cone-shaped spines. These spines were not bones, but hardened skin structures and most likely served as protection against predators. The tips of the lobopods were flexible and adhesive, allowing the animal to grip surfaces and move slowly along the seafloor. For many decades, Hallucigenia was interpreted incorrectly. Early reconstructions showed the animal walking on its spines, with its soft appendages sticking upward into the water. This made the creature appear almost impossible to move and biologically nonsensical. Only in the late 20th and early 21st centuries, after the discovery of better-preserved fossils, did scientists realize that the animal had been reconstructed upside down. The legs were actually on the underside of the body, and the spines were located on the back, forming a defensive armor. Once this correction was made, the anatomy of Hallucigenia suddenly became far more logical from a biological standpoint. Belongs to an extinct group of animals known as Lobopodians. This group is closely related to modern onychophorans, velvet worms, tardigrades, water bears, and the early ancestors of arthropods such as insects, spiders, and crustaceans. Hallucigenia is not considered a direct ancestor of any single modern animal, but rather a side branch within the broader evolutionary line that eventually led to arthropods. Its body lacked true joints, yet the arrangement of its limbs and nervous system reflects an early stage in arthropod evolution. It lived approximately 508–505 million years ago, during the middle of the Cambrian period. This was a crucial time in Earth's history, often referred to as the Cambrian explosion, when most of the major animal body plans appeared in a relatively short geological interval. Hallucigenia was one of many experimental life forms that emerged during this period of rapid evolutionary innovation, when nature was effectively testing a wide range of anatomical designs. In terms of size, Hallucigenia was relatively small. Most known specimens measure between 1 and 3 centimeters in length, with the largest reaching about 5 centimeters. Because its body was entirely soft, it could only be preserved under very specific conditions, such as environments with low oxygen levels where rapid burial by fine sediment prevented decay. For this reason, Hallucigenia fossils are rare and are found only in exceptional fossil deposits. The first known fossils of Hallucigenia were discovered in 1911 in the famous Burgess Shale fossil deposit in British Columbia, Canada. These fossils were collected by the American paleontologist Charles Doolittle Walcott. At the time, Walcott misclassified the remains and assigned them to a different group of organisms. It was not until 1977 that the British paleontologist Simon Conway Morris re-examined the material and recognized it as a distinct and previously unknown organism, giving it the name Hallucigenia. Later discoveries in China, particularly in the Changing fossil deposits of Yunnan province, revealed closely related species and provided crucial new information. These exceptionally preserved fossils showed that Hallucigenia possessed a distinct head region with small eyes, a round mouth, and inward-pointing tooth-like structures. This evidence demonstrated that the animal was not headless, as once believed, but instead had a well-defined feeding apparatus. It lived on the seafloor, most likely in shallow, warm marine environments. It probably moved slowly across the substrate using its lobopodial legs. Its diet is thought to have consisted of small soft-bodied organisms, microbial mats, algae, or organic debris found on the ocean floor. The structure of its mouth suggests that it was adapted for scraping, grasping, or sucking up food rather than actively hunting large prey. It was therefore likely a slow-moving benthic feeder rather than an active predator. The exact reason for the extinction of Hallucigenia is not known. Toward the end of the Cambrian period, marine ecosystems became increasingly competitive, with the emergence of faster, more mobile, and better protected animals. Soft-bodied, slow-moving organisms like Hallucigenia likely struggled to survive under these new ecological pressures and gradually disappeared. It did not evolve directly into another known animal, but its general body plan and anatomical features contributed indirectly to the evolutionary foundation from which later arthropods arose. Today, Hallucigenia is regarded as one of the most important examples of how early interpretations in paleontology can be overturned by new discoveries and technologies. Its history shows how fossil evidence, when combined with careful reanalysis, can completely transform our understanding of ancient life and reveal the extraordinary diversity of forms that existed during the earliest chapters of animal evolution.